Hey everybody, let's give this problem a try. So we want to use the node voltage method. We have two dependent sources. So let me just start labeling nodes. So there's a lot in common here, right? So I'm just going to choose that as my reference, and I'll just label the other essential nodes. Okay, and then notice that I have this voltage source between these two essential nodes, which means this is a supernode right here. Okay, so let me write KCL at the supernode. So I got over here, that's VA over 20. And then over here, VA minus VB over 2. And I just noticed that we already know VB is 20 volts. So that was easy. Okay, so that's 20 volts. Can I just write 20? Okay. And now back to this supernode. All right, so we're over here now. So VD minus VC over 4 over here. VD over 80. And then this is KCL, right? I'm writing the currents. So what's the current here? It is this, 3.125 V delta. Okay, what is V delta? Right here. Okay, which side is higher? See the plus? So this side is higher than this side. So it's VB minus VC. V delta is V, can I just write it? How about I'll write it like this. V delta is VB minus VC. Okay, so I got one equation. What other essential nodes? I got this one over here. So I'm going to write KCL for node C. So let me go this way. VC minus VB. Oh, okay. VB is 20, right? So VC minus 20 over 1 plus, over here, VC over 40. Then over here, VC minus VD over 4. Okay, and what else? There's a relationship between VA and VD. Which side is higher? See the plus sign over here? VA is higher. VA is higher than VD. By how much? This much. 35I phi. Where is this current? It's right here. So see this resistor right here? Let's just use Ohm's law. So this current is VC over 40. VC over 40. Okay, so I have three equations, three unknowns, VA, VC, VD. So why don't I gather it as a matrix and let's have the computer solve it for us. So let me kind of just rewrite them a little neater. Okay, so let me gather terms for VA. 1 over 20, 1 over 2. That's it. Okay, so 1 over 20, 1 over 2, VA. Okay, VC, minus 1/4. And this minus 3.125. Okay, so minus 1/4 minus 3.125. Okay, and then VD here, 1/4 and 1 over 80. Okay, 1/4, 1 over 80. And then constants minus 10 on the left side. If I move it on the right side, that becomes positive 10. And then VB is 20. Okay, so 20 times 3.125 is 62.5. It's positive 62.5, but if I move it on the other side of the equation, it becomes negative 62.5. Okay, next equation, equation 2. Okay, VA, none. I'm just going to write 0 VA kind of as a placeholder. VC, 1 over 40, 1 over 4. 1 over 40, 1 over 4. Okay, VD, let's see here, minus 1/4. Oh, I forgot to write VD over here. Okay, and then constants, right here, minus 20, and if I move it on that side, it becomes positive 20. Okay, and then last equation, I got VA, I'll just write a 1. And then, let's see, 35 over 40 VC. If I move it on that side, it becomes negative. Negative 35 over 40. Can I just write 7/8? VC, and then minus 1. Okay, so there's our matrix, right? Right, this, right? These are the coefficients. Oops. These are the coefficients. So that matrix goes here times VA, VC, VD equals negative 52.5, 20, 0. Okay, so let me pause and then switch over and I'll type it up in Octave. Okay, so I just typed it up. So that matrix is just right here. I didn't even bother trying to simplify any of that. I just typed it in as is. And then here's that matrix on the side. And let me just solve it. This is VA. This is VC. This is VD. All right. And what was the question? Oh, okay. Find the power delivered by the 20 volt source. Okay, so actually, we know all the node voltages, which means we can figure everything out. We need this current right here, I for the independent source. So if we just look at node B, we can just write KCL, like VB minus VA over 2 plus VB minus VC over 1 plus IS. Okay, let me, okay, there. So KCL for node B looks like VB, VB is 20. 20 minus VA over 2. I went this way, right? Now going this way. 20 minus VC over 1. And then here, plus IS equals 0. So the source, the current would be VA minus 20 over 2 plus VC minus 20. Okay, and then just plug this, right? Plug this in there, plug this in here, and there's the current. And then if you want the power is voltage, 20 volts, times this current. And then that would be the power. I can type this up. Okay, so I just typed it up in Octave. So VA is this first element of the solution. VC is the second one. And then I just typed the same formula. So this will be the current, and then the power is the current times the voltage. So let me just run that. The current is 30.125 amps, and then the power is 602.5. Well, negative, it's being delivered. So we're delivering 602.5 watts. Okay, hope that was helpful. I'll see you in the next video.